Hello, and welcome back to the fourth and final episode of this difficult age word problem. And just to sort of recap, we first took a look at this paragraph, and we determined that we could reduce this paragraph to this equation. We then took a look at the second paragraph and found that we could reduce it to this equation. And lastly, we took a look at third paragraph and reduced it to this equation. And now we have three equations. 1, 2, 3, and three unknowns, which would be t, j, and m. And so we can solve the set of equations for these three unknowns, and we can determine Jane's age, Mary's age, and Tim's age. So let's go ahead and start that process. First of all, we're going to take a look at the top equation, which of course it's not simplified. We got some t's that we can combine, some m's we can combine, some numbers that we can combine, so we can reduce this quite a bit. Instead of distributing this 1/2 to each of these, let's go ahead and just multiply both sides by 2. So we're going to multiply this side by 2, this whole thing, and multiply this whole thing by 2 over here. So you can see that half just kind of goes away when we multiply it by 2. So we'll leave all this was in parentheses, we'll just leave there, and then we have the 2 times m minus 8. So let's go ahead and distribute that 2. And we can distribute this 5 while we're at it. So having done that distribution, we are left with a bunch of items we can combine, and we can do this all in one step. So basically we can add plus m to both sides, get rid of that minus m over here. We can add 16 to both sides, get rid of that. We can simplify this right here to 6t, and if we go ahead and add those to both sides and work that out, we end up with 3m equals 6t plus 27. And from here we can just go ahead and divide each of these by 3. And if we do that, we end up with m equals 2t plus 9. So now we have solved for m, and the nice thing about solving for m here is that now we have this equation for m. We can go ahead and plug that in to one of the other equations. So that's going to be our next step. We'll take in that second equation that we had. Starting from here, we'll take in this second equation. And notice I'm going to call m in red here just to show where I'm subbing it in. So what I'm going to do here is take this equation for m, I'm going to sub that back in for m up here, and now this equation right now it has three unknowns, t, j, and m, but when we sub this in, it's just going to have two unknowns. It's just going to have j and the t over here, and the t that's going to be part of m. So we're going to simplify this equation a little bit by doing that. It's not going to give us a final answer, but it's going to get us closer to that direction. So first let's go ahead and sub in that m, and having done so, we just get the 2t plus 9 out here. Having subbed that in, we can go ahead and get rid of this, and we can just get rid of these parentheses too while we're at it for our next step here. And now we can simplify this a bit. Let's go ahead and subtract 40 from both sides. And let's go ahead and subtract 2t from both sides. If we do that, we can get rid of this 40 here, and we'll get rid of this 2t over here. And we end up with 11t equals 8j minus 31. Now we're getting pretty close, but again, if we just want to solve for t here, we can divide each of these by 11. So let's do that. And we end up solving for t is going to equal negative 31 over 11 plus 8 over 11j. Of course, this one just went here, and this 8j went over there when we divided it by 11. And I'm going to make this t in yellow just to show how we're going to sub it in later. So now we've solved for m in terms of t, now we solve for t in terms of j, and we're getting pretty close here. But the next thing we're going to want to do is go back to our initial equation and plug this in for t so that we can get m in terms of j and t in terms of j. If we get m in terms of j and t in terms of j, then we can take any one of these equations and we can solve for j, and we can get a value for j that we can plug in to find t, and we can plug in to find m. So we're going to go back to our equation. Let's get rid of this stuff. And we'll go back to that equation we had for m. But this time we're just going to plug this in for t, back in for m. We're going to plug this right back in up here. So having done that, we end up with this t in the middle. We'll go ahead and distribute that 2 to each of these. And having done that, we've solved for m now in terms of j. And that's about as simple as we can get it. So we'll leave it at this, and now we can go ahead and get rid of these two. And now we can bring in that third equation that we had. This is our third equation, but now you can see that we can plug in this t equation here for t. We can plug this in for m. And having done that, we will have a full one equation that's just in terms of j. So we'll have one equation, one unknown, and with that we can finally solve for j. So if we go ahead and plug in for t and plug in for m, we get this somewhat of a cumbersome equation here. However, the good news is it's all in terms of either just numbers or in terms of coefficients to j. So this is actually going to simplify down pretty nicely. Also helpful is the fact that these numbers kind of work out to make it somewhat simple. But before we get into this, let's go ahead and cross this out, make some room, get rid of that. And our first thing we're going to want to do here is just go ahead and distribute our 4 and distribute our 3. Having done that, this 31 becomes this 124, that 8 becomes 32, that 9 becomes a 27, that 62, the 186, 16 is 48. Now, the next thing we're going to want to do is kind of get rid of these 11s on the bottom because they're going to be cumbersome if we don't deal with them. So let's go ahead and multiply everything by 11. The left side by 11, and we'll multiply everything on the right side by. If we do that, it simplifies a bit because those 11s just kind of cancel out on the bottom. That 1 becomes an 11, that 27 becomes 297. These 11s sort of cancel out, and that 7 becomes 77. And now this is getting pretty simple now. Let's go ahead and get rid of these up here, make some room. And having done that, our next step is going to be just getting all the j's on our left over here and getting all the numbers on our right. So in order to do that, we want to get rid of the j's on this side. So we're going to add 48j over here, and we're going to subtract 77j. We do the same thing over here, plus 48j minus 77j, and we want to get this number over here on the right side, so we're going to add 124 to both sides as well, plus 124. Having done that, we end up with all our j terms on the left here, and we end up with all of our number terms on the right. And it just so happens that these numbers work out pretty well. When I add all these j coefficients, add all these numbers on the right, I end up with 3j equals 24, which is nice because they both divide nicely by 3. And dividing them by 3, we end up with j equals 8. So now we're making some real progress here. J equals 8. Jane's current age is 8 years old. And having found j, now this is going to make it easier to find m and t, which will be our next step. So let's go ahead and try and find m next. But recall, let's get rid of these equations here. Recall that we have an equation for m in terms of j. So let's bring back that equation here, and all we're going to do now is sub in j equals 8 for this j here. So we do that, we just multiply this 16 term by 8. That 16 times 8 is going to become 128. I also multiplied this 9 by 11 over 11 just to get it in the same terms as these other ones. So having done that, we can just add 99 minus 62 plus 128, and we get 165 over 11, which thankfully simplifies to 15. So bam, just like that, we found Mary's age now, m equals 15. So let's get rid of this stuff, simplify it up a bit. J equals 8, m equals 15, and now we're trying to find t. And what better way to find t than go back to that equation with m and t in it that we used earlier? We had an equation m equals 2t plus 9. Again, there's a lot of different equations you could use here to solve for t at this point. I think this one might be one of the simpler ones, so that's why I wanted to use this. But what we're going to do here is try and solve for t, so we're going to just subtract 9 from both sides. Oh yeah, let's go ahead and just switch these sides so we got t on the left and our m and number on the right. So having done that, we end up with 2t equals this. and we'll go ahead and divide both sides by 2. We end up with t equals m over 2 minus 9 over 2, but we know what m is, so it's probably a good time to go ahead and sub that in here. We know m equals 15. So having subbed that in, we end up with 15 over 2 minus 9 over 2. We can just subtract 9 from 15, which gives us 6. So t equals 6 over 2, which is also known as the number 3. Alright, so now we have j, we have m, and we have t, and we have our solutions to this difficult age word problem. So just to summarize this, Jane is going to be 8, Mary is 15 years old, and Tim is 3 years old at this current time. And that, ladies and gentlemen, is the final answer. So having answered this question, I'd like to leave you with another question, and that is, why is this question assigned to a 13-year-old in the midst of a bunch of other homework problems? If this question has taken me over 45 minutes to go through it step by step on video, and this is a step-by-step process that was the right process. There's all kinds of wrong roads you can go down and end up in. So doing this the right way, it's going to take you about 45 minutes. That's a lot of time, that's a lot of work. And I kind of suspect that some of the teachers that may have assigned this problem haven't actually gone through it and realized how long it is. But nonetheless, it's a challenging problem. Hi. How was the time? It's about time, Z.
We have a stuffed animal mountain happening.
Mountain of love. Good?
Check out those socks.
Good? Alright.
Set, my dear?
Sure you want this cheese though?
Eleven's such a hard time because that's when you're like hungry. Do you want your goldfish? Oh, okay. Alright, lovely lady.
Thanks for grabbing her.
Oh, absolutely. Oh, do you want to read that before we go?
Let me make sure for that one, actually. Sorry.
Your room is so festive. I mean, with all the gold cards, really long bowl. Check this closed.
Yeah, thanks. Alright, see, Z, I'm gonna go for a jog, so I might be a little late getting back. But I'll see you pretty soon, okay?
Thank you.
But having answered this problem, I'd like to leave you but having answered this question, I'd like to leave you with a question of my own, and that is, how is this problem end up and that is, how does this problem end up on a 12-year-old's math assignment in the middle of a bunch of other homework problems? Seems a little out of place there, given that this problem has taken me 45 minutes to do step by step in a video that has been going really quick and with no errors, where in this type of problem you're very likely to make a lot of mistakes, which I confess I did getting through this. So seems a little out of place for a 12-year-old, but hey, it's challenging, and if you're 12 and you figure this problem out on your own, then my hat goes off to you. But for those of you who may have not have picked up on this problem immediately, hope this video has been of use to you. Take care.